Hi everyone, welcome back. In this lesson, we'll cover influential points in regression analysis. Influential points are data points that have a disproportionate impact on the fitted regression line. Let's get started. In this video, we'll demonstrate what outliers and high leverage points look like on a scatter plot and explore how each type of unusual observation affects the fitted regression line. Here is a scatter plot showing a clear linear trend. The gray line is the fitted regression line through these data points. Let's add a new point to the plot. Take a look at where it falls relative to the fitted line.
Do you think this is an outlier or a high leverage point?
This point is an outlier. An outlier is unusual in the vertical direction. Its y value is far from what the trend predicts for that x. Notice how the part of the red regression line that lines up vertically with the outlier is pulled upward and away from the original gray line. This is due to the influence of the outlier, making this specific outlier an influential point. Now let's add another unusual point, far to the right of the other data. Do you think this is an outlier or high leverage point, or maybe both? This point is just a high leverage point. A high leverage point has an unusual x value. It is unusual in the horizontal direction. However, because this point falls right on the fitted line, it is not an outlier. It is not unusual in the y direction. Now, consider this point. It also has an extreme x value, but notice where the y value lands.
Is this point an outlier or a high leverage point?
This point is both a high leverage point and an outlier because it is abnormal in both the horizontal and vertical directions. In this example, the impact on the regression line is significant. Notice how sharply the slope drops compared to the original gray line. These statistics highlight the impact of different types of potentially influential points on regression analysis. The presence of outliers and high leverage points can significantly affect the regression model, leading to changes in the coefficients, r-squared, and the residual standard error. In the example we looked at, the outlier was influential because it pulled the regression line upward and away from the original gray line. Notice how much it changed the intercept, slope, r-squared, and RSE. The high leverage point was not influential, as demonstrated by the fact that it barely changed the fit of the regression line. The point that was both an outlier and high leverage point also had a large impact on the fit of the line, reducing the r-squared from 0.97 to 0.14 and increasing the RSE from 0.74 to 4.39. Outliers are not always influential points. Consider this data set. Although adding an outlier to this data set shifts the intercept up slightly, it barely impacts the slope and fit of the regression line. However, even though the impact of this outlier is minimal, removing an outlier will always improve the fit of the line. The same cannot be said of a high leverage point that is not an outlier. Removing a high leverage point will not necessarily always improve the fit of the line, especially if it falls on or near the regression line. Therefore, simply omitting unusual points to improve regression fit is not always advisable. So what do we do once we identify high leverage points? Let's explore the options. The first option is to include the high leverage observation in the summary statistics, but comment on its effect. If the high leverage point's impact on the regression is minimal, it might be reasonable to retain it in the analysis. The second option is to delete the observation. Exclude it from the dataset if it is deemed not representative of the larger population. A useful approach is to present the regression analysis both with and without the high leverage point. The third option is to choose a different explanatory variable altogether. If the current variable is causing problematic leverage, replacing it with a related but better behaved variable can help. For example, instead of using the square footage of an apartment, the number of bedrooms can be used as a proxy for size. The fourth option is to apply a nonlinear transformation to the explanatory variable to mitigate the leverage effect. For instance, a continuous variable with extreme values could be converted into a binary indicator variable. Now let's formally define leverage in terms of formulas. But before we talk about leverage, let's pull in some notation from the video on multiple linear regression. Recall that the projection matrix H, also called the hat matrix, is a matrix that projects the observed values y onto the fitted values y hat. It is known as the hat matrix because it puts the hat on y. The ith diagonal element of H measures how much observation I influences its own fitted value. This is represented by the leverage statistic H sub II. A point with extreme or rare predictor values sits far from the rest of the data, so the regression line has to bend toward it more, giving it high leverage. Leverage values always fall between 1 over n and 1. The average leverage across all observations is h bar, which equals the sum of all h sub I divided by n. This simplifies to p plus 1 over n, where p is the number of predictor variables, not counting the intercept. An observation is considered a high leverage point if its leverage exceeds 3 times the average leverage. Large leverage values suggest that an observation is distant from the other observations in the space of the explanatory variables, and thus has a disproportionate effect on the regression fit. For simple linear regression with a single predictor, the leverage statistic has a closed form expression. H sub I equals 1 over n plus the squared distance of x sub I from the mean x bar divided by the total sum of squared deviations of x from its mean. This equation shows that the farther x sub I is from x bar, the higher the leverage. Thanks for watching. For a comprehensive written course, hundreds of practice problems, progress tracking, and AI-assisted tools, visit the Actuarial Nexus. See you in the next lesson.